In our worksheet, we're at the bottom of page 488, and what we're going to do now is we're going to start solving problems where we know the second derivative of a function, and we know a few other details about the function, and we need to figure out what the function itself is. So let's see how we're going to tackle that. All right, so right now we know that the second derivative of the function is equal to 2. And they're also telling us that the first derivative of the function evaluated at 2 is equal to 5, and the function itself evaluated at 2 is equal to 10. And so we want to find the exact function that satisfies all of those conditions. All right, so let's think about that. The first thing we can do is we can say, given the second derivative of the function, I can figure out that the first derivative of the function has got to be an antiderivative of the second derivative, right? Because the second derivative is the derivative of the first derivative. So turning that around, the integral, the indefinite integral of the second derivative has got to be equal to the first derivative. Does that make sense? Let's go through this example and maybe it'll be a little bit clearer. So let's take the indefinite integral of 2 dx. What is that equal to? Well, that is equal to 2x plus some constant. Okay, so I know that the first derivative of f has got to be equal to 2x plus some constant. All right, let's double check our work. If the first derivative is 2x plus some constant, what would the second derivative be? It would be the derivative of this. The derivative of 2x is equal to 2. The derivative of the constant is 0. So that gives us that the second derivative of x would be equal to 2. Okay, so this looks like the problems we've seen before, except we've got an extra piece of information here. We know that f prime of 2 is equal to 5. So given that, we can figure out exactly which value of c makes this true by substituting 2 in for x in this equation. So f prime of 2 is equal to 2 times 2 plus c. They tell us that f prime of 2 is equal to 5. So 5 is equal to 4 plus c. And so what value of c makes that true? Well, you subtract 4 from both sides and you get that c is equal to 1. So because we know a value of f prime, we're able to figure out exactly what the value of f prime is. So f prime of x has got to be 2x plus 1. All right, does that make sense? This is the function that satisfies f prime of 2 equals 5, and the derivative of it is equal to 2. All right, so that's pretty cool, except we need to figure out what f is. So we're going to do this step one more time. All right, so now I want to figure out what's the antiderivative of 2x plus 1 times dx. What is that antiderivative equal to? Well, the antiderivative of 2x is x squared. The antiderivative of 1 is x. And then we have to add some constant term. Okay? So since that's the antiderivative of f prime, we know that f of x is equal to x squared plus x plus our constant. Maybe I'll call this c prime, just to make it clear that it's maybe a different constant than the constant we had in the first round. But how can we figure out what c prime is? Can we do it the same way we figured out what c is? Yeah, we can, because we were told here that f of 2 is equal to 10. So we'll do the same trick we did before. So f of 2 is equal to 2 squared plus 2 plus c prime. And I know that that's equal to 10. So 10 is equal to 4 plus 2 plus our c prime. So 10 is equal to 6 plus c prime. Subtract 6 from both sides, and we get that c prime is equal to 4. And so putting that back into our equation up here, we have as our final answer that f of x is equal to x squared plus x plus 4. So what we have just identified is we have identified the one and only one function whose value at 2 is equal to 10, whose first derivative at 2 is equal to 5, and whose second derivative is equal to 2 everywhere. Okay, so we did that by finding the antiderivatives of the second derivative and then later of the first derivative, and then plugging in the one condition that we knew in order to find out what our constant value had to be in order for that to happen. Okay, so now that you've got this example, see if you can do the second problem there. And I will do it in the next video, but see if you can unwind it yourself. It's going to be the same process, just maybe a slightly more complicated function, but shouldn't be that bad. Do your best with it.